Hello, good morning, students. So in the previous video we have done till exercise 15A. So now we are going to start 15B. Okay. So before we start exercise 15B, I want you all to go to this theorem, basic proportionality theorem. Okay, with application. It's in page number 215. Please go to the theorem number 1, and then read the statement. Okay. The statement of this theorem is a line drawn parallel to one side of a triangle, okay, so this line drawn parallel to one side of the triangle, okay, divides the other two sides. So this line is drawn parallel with this side, so therefore these two sides, the other two sides, divides the other two sides proportionally. Okay, so the meaning of this is, in a triangle, if I draw a straight line DE parallel to BC, or you can draw in any of the form. Okay, if D is parallel to BC, then this DE divides the other two sides proportionally. Proportionally means this DE divides AB in the ratio, this D divides AB in the ratio AD is to BD, that is AD by BD will be equals to AE by EC. So this is your proportionality theorem. But when is it possible? Only when DE is parallel to BC. Got my point? Okay. So now with this concept, we will be starting our exercise 15B. Exercise 15B, question number 1. Okay. The figure is given to you. Refer to the figure. In the figure, triangle ABC is given to us. And out here, DE is a side which is parallel to BC. D is a straight line which is parallel to the side BC. Okay. So all in all, it is a triangle. DE is parallel to BC. The values are given to us. The value for AD is 3 and the value for DB is 5. Okay. Analyze the values properly, boys. AD is equals to 3. DB is equals to 5. And one thing we know that this and this are parallel. So from the theorem number 1, what we have learned is that if this and this are parallel to each other, then this DE divides these other two sides proportionally. That is AD by BD is equals to AE by EC. Okay, the first question out here, we need to find the value for AE by EC. We need to find the value for AE by EC. So just now we have learned the theorem. Given these, divides AB in the ratio 3:5. According to the question, 3:5. So therefore AD is to BD is 3:5. Okay, so this is the value for AD by BD. Again, what we know is that DE and DE is parallel to BC. We know that DE parallel to BC, DE parallel to BC. So once this is parallel, from the basic proportionality theorem, what we understand is AD by BD is equals to AE by EC. So hence the value for this we know already. This is 3/5. So the value for AE by EC is also 3/5. This is number 1. Okay. We move to number 2. We need to find the value for AD by BD. We need to find the value for AD divided by AB. AD divided by AB. From here till here it is 3, and from here to here it is 5. Okay. So what we'll do? AD by AB. So hence that is this. AD by AB is equals to AD by, AB means, from the figure we know AB means AD by BD, AD plus DB. The value for AB, I can write this AB as sum of AD plus DB. Okay, so replacing my AB, I am replacing my AB by AD plus BD. So AD is 3, DB is 5. So 3 by, how much will I get? 8. 3 by 8. Okay, question number 3, we need to find AE by EC. Similarly, in the same way, AE by EC. We need to find the value for AE by EC. The value for this is 3 and this is 5. So hence it is going to be 3 by 8. Which is this, 3 by 8. Right? So this is till part 3. Now part 4. Part 4, we need to find the value for BC. Find the length of BC on the same figure. On the same figure, boys. On the same figure, we need to find the value for BC when DE is how much? When DE is 2.4. When DE is 2.4, I need to find the value for BC. Okay, now, on this figure, as we know the laws, or as we know the axioms of similarity, okay, when can I tell two triangles are similar to each other? Now, if you look on this figure, there are two triangles. One is ADE and other one is ABC. Now I can tell these two triangles are similar to each other. I'm not telling congruent, but they're similar in shape. Okay, triangle ADE is similar to triangle ABC. You tell me how? These two are similar. How? Because angle A is common. ADE, ABC, angle A is common. Now this angle is equals to this angle, and this angle is equals to this angle, because they are corresponding angles. So hence by angle property, I can tell these two triangles are what? Similar to each other. And once they are similar to each other, the corresponding sides are in proportion. That's what we have learned in exercise 15E. Okay, the moment two triangles are similar to each other, I can tell these two triangles are what? Similar, and the corresponding sides are in proportion. So what do I mean by that? The corresponding sides proportion, AD by AB is equals to DE by BC and is equals to AE by AC. Once again, I'm repeating, if two triangles are similar to each other, AD, the corresponding sides are in proportion. AD by AB is equals to DE by BC is equals to AE by EC. Okay, which is this line. Right? By angle property. Now what I'm doing is I'm using the first two ratios. What will I get? AD by AB is equals to DE by BC. Okay, same thing goes out here. Now what we know is, that DE by BC, okay, I know the value for AD by AB. AD by AB, how much? 3 by 8. This is part 2, I guess, yes. AD by AB is how much? 3 by 8. So replace this value by 3 by 8. Okay, so DE by BC, I'm now getting it as how much? 3 by 8. On here also, I know the value for DE. So put the value for DE. The value for DE is 2.4. Therefore, 2.4 by BC is equals to 3 by 8. You cross multiply and find the value for BC. The value for BC will be 6.4. Okay. In the similar way, number 5 also. Number 5 as well. But out here, the value for DE is out here the value for BC is given to us. In the same way you can do number 5 also. Very same, easy. Okay, we now move to question number 2 is similar, so number 2 you can do it yourself. And now I'm moving to number 3. Read the question. If you read the question, you'll understand. A line PQ is drawn parallel to side BC. So again, a triangle ABC is given to us. ABC is a triangle given to us. This line PQ is parallel to BC. Again, the same kind of things. If this is parallel to each other, then PQ divides this and this proportionally. AP by PB is equals to AQ by QC. Right? And again, these two triangles are also similar to each other by angle property. Okay. So what is the question asking us? Let's read the question. If AB is equals to 9, AB is 9. From here till here, it is 9. Okay. CA is 6, CA, that is AC is 6, right? AQ is 4.2, AQ from here to here it is 4.2. You're asked to find the length of AP. Find the length of AP. Okay, now let's see how we can do this. As PQ is parallel to BC, one thing I can write, that this PQ divides AB and AC proportionally, that is AP by BB. AP by PB is equals to AQ by QC. This much we can write, equation number 1. Now what we'll do out here is, I'll use componendo. The property of componendo tells us that in a ratio like this, okay, I can always write AP numerator divided by numerator plus denominator is equals to numerator divided by numerator plus denominator. Okay, once again, numerator by denominator is equals to numerator divided by numerator plus denominator, AP plus PB, and numerator divided by numerator plus denominator, right? So this is our property componendo. The reason I'm doing this, why am I doing this, is because now see, AP I need to find, AP remains as AP. AP plus PB, if you look on the figure, AP plus PB is AB, right? Isn't it? Which is 9. That's the reason why I'm using this property componendo, right? So therefore I'll be getting AP by AB is equals to AQ by QC. And from here, AP I need to find, keep it as AP, keep it as AP, AB is 9, AQ is 4.2, okay, AC is 6, you cross multiply, you'll get the value for AP very easily. Okay, so in this video till here, now the next set of videos which I am uploading, or which I am giving you the link, will finish this exercise. So I expect you all to complete this exercise on your classwork copies and then send it to me. That's going to be your assignments, right? Thank you, boys. I'll see you in the next video.